Hi, I'm Figment, and today we're going to start on a new unit, not the subtractor, but a little half-rack device called the PH90 phaser. Now I chose to follow up with the PH90 phaser because the subtractor uses phase it has a built-in phaser for its oscillator 1 and oscillator 2, and it's a topic we kind of covered, well, I did cover it in the subtractor videos, the previous ones, so I figured it would be in the same vein to go ahead and talk about a different phase unit, the PH90. It's different than the built-in phasers that come along with the oscillators 1 and 2 of the subtractor for a couple of reasons. I'll try and explain them and try and get this in one video if possible. The main difference before we jump into the PH90 is that these two oscillators are each phase unit is dedicated to the oscillator it's tied to. Um, this phaser basically has a phase effect to whatever audio signal is running into it. So automatically right there, this phaser is a little different, quite different. Um, Another huge difference in this phaser is that it's a four chain or four band phaser or four stage phaser, if you will. What well I'll try and explain what it does, and that should explain what that means. Basically what it does is any audio signal that runs through this phaser um, basically gets four frequency bands of that audio signal um, affected, and they are turned 180 degrees out of phase. Once that happens, that affected audio signal with those four bands out of phase are added back to the original unaffected signal, and then you get this phase effect. Um, if you didn't know this, what happens when you take an audio signal and duplicate it, and then take the duplicated signal and turn it 180 degrees out of phase and play them at the same time, they both cancel each other out, audio cancellation. In this case, this phase is only affecting four little frequency bands and taking them out of phase. So you're still going to hear sound, but you're going to get a phase effect because those four bands are out of phase. It's kind of like a notch filter, if you will, but having four of them on the filter frequency spectrum in a nutshell. So, with that being said, I will try and explain how these notches contribute to that idea I just tried to explain. The frequency knob here basically sets the first frequency band to be affected. So, if you set it here, let's say, then there would be three frequency bands that follow that would come after this first one. That's your four frequency bands right there. So this knob, if you set it here, your first frequency band would be affected here, and then the three would follow after up top here. So this knob kind of slides the four frequency bands around, but you want to use the marker to set where you want your first affected band to be, and then just know that there'll be three concordant bands that come afterwards. Um, this split knob here basically widens the distance between the bands, so equidistant from each other. So if you set this frequency band here, the first one would be here, and if your split was very low, the frequency bands, the three that follow after it, would be very close together and following this first one. If you spread it out a little bit, the frequency bands that follow the three would then be more spaced out from each other after this first one. So it basically sets the distance between the frequency bands themselves. The width knob basically sets the width of the actual bands themselves. So it doesn't change their distance from each other, but it makes them, if it's closer to the left, it makes them more thin. Farther to the right, it makes them more fat, and anywhere in between, you know, uh, those two extremes. So these three knobs are integrally linked. The frequency knob selecting where the first affected frequency band takes place and then sets the following three. The split sets the distance between um, the bands themselves, the distance between them, equidistance, so they would all be equally spaced. And the width knob sets the width of the actual bands. Are they thin, or are they thick, are they medium sized, whatever. The LFO here basically modulates this frequency knob. So if you remember LFOs from the Subtractor video, it's pretty straightforward. It's gonna modulate that knob. The rate will be how fast it modulates it, and the F mod knob will affect the frequency depth of the modulation. The sync button is basically just a tempo sync, so if it's off, you'll have a free rate. If it's on, you'll have a tempo synced rate. So, fairly simple. This LFO, you can't change its waveform. I would assume it's a sine wave, although I'm not totally sure. But it doesn't matter because you can't change it anyway, so there's that. The feedback knob here, I almost want to sit back and say it's like an amount knob, but it kind of isn't. But audibly, it will make the phase effect more drastic as far as your ears are concerned. It does that by adding little, emphasis points or little emphasis or res points right before each of the four notches. So if you're going to have this frequency cancellation or this phase effect for these four notches, then right before each notch, this feedback is going to intensify by kind of emphasizing the frequency right before each notch. You're going to get the phase effect is going to be way more pronounced. It's weird. If you punch this feedback knob all the way up and you have a really low F mod setting, you almost get this kind of weird singing phase effect. But it's really something you have to sit down with an audio signal and just play around with. Maybe I'll do a demonstration on that in a later video because we are approaching the 10-minute marker. But in a nutshell, that's how the PH90 works, or that's what it's going to do to an audio signal, and that's what each one of these knobs do. It's a really useful little half rack effect if you want to add phase to something, or some kind of an instrument, or like a lead or a guitar sound, or even vocals or whatever. Phase has a very unique sound that once you identify and phase well, you can just point it out like, oh, that's phase, or that's phase, or it's used a lot. So my number one tip would be to experiment and play around with this device, and more importantly, just have some fun with it. Hopefully that kind of got your brain going, gave you some ideas, and maybe inspired you to use more PH90s. Anyway, questions and comments, post them below. Like I said, I'll maybe do a demonstration video to give you kind of a sonic idea next time of what this guy can produce. Anyway, until then, eat some chips. I'll talk to you later.